What's happening? Stark here. Lesson on limits involving infinity. Oh yeah. Calculating limits as x approaches infinity. And we're going to find some asymptotes in this lesson. So the main thing is this x approaching infinity deal. Alright, so and that's related to end behavior because the end behavior of this function is this way and this way. Usually for corporations, business, industry, we're looking what's going to happen. What's the end behavior of our business model? End behavior model, okay? So y equals 1 over x is a great example of how we can find limits, infinite limits, because we could find the limit as x goes to infinity this way. So that equals 0. And we could find the limit as x approaches negative infinity, and that equals 0 as well. Okay? So it's like you're on the curve and you're approaching infinity. You're on the curve, you're going to the right, you're on the curve going to the left. So you can really start at any point. You know, if you're here and you're approaching the left, well, you're going to go up and then you're going to kind of follow back up in the curve there. So if you're in a calculus class, then you know how to identify horizontal asymptotes by the graph and perhaps maybe doing some algebra. But the connection to calculus is we're using limits to do that. So let's just make sure we understand how to do that with limits, and then we can apply it. So here it is, just a definition of horizontal asymptotes related to limits. If you take the limit as x approaches infinity of f of x and it equals b, some constant, 5, 6, 100, or the limit as x approaches negative infinity is that same value, then what you have is a y equals b is a horizontal asymptote. Okay, now recall that y equals b, that's a horizontal line because y is always b, therefore it makes a collection of points. Y is b, the height is b, the height is b, makes a collection of points that are horizontal. So let's take a look at an example here. F of x is this function. I recommend that you graph that right now in a standard viewing window. Before I hit graph, I always hit zoom standard. Unless it's a trig function, I hit zoom trig. Find all horizontal asymptotes. So what happens when I graph that, you can hear me clicking around, is that I end up looking, it looks like this sort of walk like an Egyptian deal, kind of looks like x to the 1/3. So in order to find the horizontal asymptotes, I'm just going to, well, the first thing is to graph, okay? Step 1, graph. And I get to see this curve, and you could trace it. You could find the value of it when, I don't know, you could plug in x equals 100 or something, or 10, or 20. See how it goes. The example that I usually give, sometimes it only requires 1, 2, 3, 4, 5, 6 values that you enter, and you can see where it's going. 2 is you find the limit, okay? So let's take a look at how that goes. So the limit as x approaches infinity of 3x plus 1 over that stuff. Well, like I said, when you graph it and you trace it, you could start to see where that value goes, but what we could do is we could literally plug this infinity in, and we get 3 times infinity plus 1 over infinity. Now, absolute value of infinity is infinity. It's positive. We're just plugging in the positive one. And we're going to do plus 2 here. So what happens is when infinity is multiplied by 3, the 1 does not matter. So we get 3 infinity over infinity. Now, this is a crazy math, okay? Now, just imagine infinity is kind of like an x. We divide those out. All right? So then we get our horizontal asymptote is 3. But what is that? Just 3? No, that's not an answer. Y equals 3. Just like our previous definition says, that y equals b is the horizontal asymptote. So here it is, y equals 3. And that corresponds to the fact that whenever we take the limit of a function, it's always a y value. Okay? So the limit as x goes to infinity, limit as x goes to negative infinity, whatever you get out, it's going to be a value of the function in output. And you could try plugging in negative infinity. That gives you the absolute value, and you'll end up getting, oh, actually, we should do that. Never mind. So here we go. So we got to do the negative one too. Oh my goodness, because that was part of the definition. So here it is, as x approaches negative infinity, and you can see it from the graph that there's a negative asymptote as well. So we'll do 3 times negative infinity. And I'm going to drop the 1, take a shortcut, and then negative infinity absolute value. So that becomes negative 3 infinity over infinity, because it's absolute value. And then the infinities cancel, and I get negative 3. So my answers are y equals 3 and y equals negative 3. Phew, dodged a bullet there. Okay, so I just have one more example for you, and that will help us complete the target. So far we have calculated limits as x approaches infinity and found the horizontal. So let's take a look at vertical. So here we go, a vertical asymptote, Now that's just kind of going, let's see, horizontal we took the limit as x approaches infinity, and now we're looking for what limit. This is kind of like when you do trig functions, you plug in a value and you're getting out a value, and then you do sine inverse. So this is kind of like an inverse trig deal. We're trying to find out what a value is giving us an infinite limit. Okay, so the limit here exists, but it's not a real number. It's infinity or negative infinity. So if these two things are true, if for some value of a, the one-sided limit is infinite, then x equals a is a vertical asymptote. Okay, so that's the formal definition. Let's say that. Formal definition. So here's 2 quick examples. Find the vertical asymptotes of these 2 functions. So the first thing I'm going to do is graph. And when I graph this function, I end up with, here I'll do this kind of small here. I end up with a function that kind of looks like this. I'll do a different color. Function that looks like this. Oh, by the way, that's an even function, not odd. It's an even function, symmetric about the y-axis. And then the second step I'll do is the limit deal. Okay, so the limit, this is graphical. Okay, and you use your trace function. But along with that, we could use the idea that the denominator is telling us there are some issues, and the asymptotes happen when the denominator is equal to 0. So we're using algebra and our connection with limits now. So what values for x give us this asymptote here? Well, the algebraic thing is to set x squared minus 4 equal to 0. So you get x equals positive and negative 2. And then we look at the graph and we see, as x approaches negative 2, the limit is negative infinity. And that satisfies this one right here. It's approaching 2 from the positive side. It's approaching negative 2 from the positive side. Same deal with 2. We go from the positive side and it approaches infinity. So these are our asymptotes down here. Okay, and then the last bit, the tangent function. I'll do a quick little graph of that, and we get something that looks like this, with asymptotes that are sort of curvy. No, they're not curvy. But this repeats itself. So infinite asymptotes, infinitely many. So this one's more of a graphical and sort of memory deal, is that if I'm on the tangent curve and I'm approaching this value where the asymptote is, I could recall that that's going to be pi over 2. So x equals pi over 2 is one of my answers. And then since the tangent function has a period of pi, then x equals 3 pi over 2 is pi over 2 and 3 pi over 2. So the answer is every odd pi over 2. Okay, so that is it as far as calculating limits as x approaches infinity and finding horizontal and vertical asymptotes. We took a look at four different types of functions, and really the main theme throughout all these is that you would graph them, you would find limits graphically, and then you could do whatever algebraic processes that will help support that and go back and forth between the two. Thanks for watching.